Hello everyone, myself Rupeshar. Today we are going to deal with trigonometry. So what is trigonometry? Trigonometry. So what does it means? What does the trigonometry says? So basically trigonometry or trigonometry, that means, so trigonometry is derived from a Greek word trigno and metron. So metron and metry both are one and the same. Metron means measurement, gno means sides, and tri means three. So three side measurement, or it is also called as measurement of three sides of a triangle. It is called as an trigonometry. So I will write it here. Tri means three, no means side, metron or metry means measurement. So three side measurement or the measurement of three side is called as an trigonometry. So what is trigonometry? Measurement of three side measurement. So let us concentrate on definition of trigonometry. So what does the definition of trigonometry says that? So trigonometry is a branch of mathematics. It is dealing with the relationship or relation between sides and angle. So what does the definition of trigonometry says that? It's a study of relationship between sides and angles of a triangle. So sides and angles. So what is angle here? What is angle? Angles means the measure of rotation. Suppose, what is the measure of rotation for this race? So angle means the measure of rotation. So angle means measure of rotation of race. Either you can also say like this. So it is one of the definition of what angle. So another one you can say like this, space. So space between two intersecting lines and angles. Lines are surface. So measure of rotation of race. So these are the race, right? So the space between two intersecting lines are surface. So what is the space between these two lines? These are the two lines, or it can also say as ray. So what is the measure of this ray rotation? What is the measure of this rotation of these two rays, or you can say what is the space between these two intersecting lines? So this is what the angle says that. So now the relation between the sides and angles of triangle. So you want to remember the one thing is, in trigonometry we are going to deal with only right angled triangles. Right angled triangle. What? Right angled triangle. So what does it means? What does the right angled triangle means? How does it look like? So right angled triangle will look like this. So it is called as right triangle. Why it is called as right angled triangle? Why it is called as right angled triangle? Because one angle of the triangle is 90 degree. One angle of the triangle is 90 degree. Then it is called as a right angled triangle. This and all the basics you will be known very well. So to revise that, so one angle of the triangle is 90 degree, then it is called as right angle triangle. Either you can say also like this, in a triangle if you have a right angle, then it is called as a right angle triangle. So you can write like that also. Let it be. So you know about right angle triangle, right? We have said, right? Now So these are all the things which are essential to study trigonometry. If you know this, you can solve the trigonometric problems. Before that, so why we need to study trigonometry? This is very important. Why we need to study trigonometry? I will take one tower. So observe here, I have one tower. Let it be mobile tower. So I will write like this. Let it be a mobile tower. So I am standing here. Okay, now I am standing here. I am seeing upside how height it is. So I need to find out the height of the tower. Can we measure this through tape itself? So everything will not be measured by tape because it may be very height, right? So you can measure like this. So observe here. So how far the distance is from tower to you? So this is the distance, right? Distance from tower to the standing person. So from here, the top of the tower to the fellow standing here. So this is what the height. So can you observe a right angle triangle here? Can you observe a right angle triangle? So using like this, so you can also measure like distance between this tower and some building is there here. So same building is there. So you can measure the distance from this tower to this building. Similarly, observe the river is here. So river is here. You need to find the width of the river. You need to find the width of the river. So how can you find? Can you measure it by tape? No, it is not possible by measuring by tape. So here you can draw a triangle. So one right angle triangle will be there. Here also the same. So the right angle triangle will be there. Either like this also you can draw. So right angle triangle will be there. Using that right angle triangle and some concepts of trigonometry, that is angles and sides of those, we will find out the heights, distance and slopes. So trigonometry is used to find, or trigonometry is basically using to find the heights, distance and slopes of these things, right? So I think you have understood the concept of trigonometry and where they are used. Now I think you are clear with an idea about how the trigonometry word comes from that Greek word trigonometron and what is the definition of trigonometry. This and all you are familiar with. Now, so I have right angle triangle. I have already said that trigonometry is only based on right angle triangles only. So I have right angle triangle here, right? Let it be named by A, B, C. You have already read the Pythagoras theorem, right? Using that Pythagoras theorem, can you identify the hypotenuse side? Which is hypotenuse side here? So the side of a triangle which is opposite to the angle 90 degree. The side of the triangle which is opposite to the angle 90 degree. It is called as an hypotenuse side. This is hypotenuse. Right. So the side which is opposite to angle 90 degree. So this side is called as an hypotenuse side. So I will consider this as either C as angle theta. So there are three angles. One is 90 degree, it is fixed, it won't change. So C is one angle, A is one angle. First I will consider C as angle. Now using that angle C, that is called theta, can you identify the opposite and adjacent side? Which is opposite and which is adjacent? So the side which is opposite to angle theta, so this side, the side which is opposite to angle theta, AB side, it is called as an opposite side. Opposite. Okay, now the side which is opposite to angle theta, it is called as an opposite side. So the side which is theta is lying, the side on which the theta is lying, that is adjacent side. So which is adjacent side here? This one. This is adjacent side. Now you have got an idea about hypotenuse, adjacent and opposite, right? So now I will change this triangle. I will do one thing. So I will write the same triangle here. So observe here, the same triangle I will write. Okay, now. So the same triangle I have written. I will, so here 90 degrees, same here. Now let us name those triangle A, B, C, right? So 90 degrees there. Here hypotenuse side won't change because hypotenuse is fixed, because 90 degrees fixed. 90 degrees not changing anywhere else. So opposite to the 90 degree, the side which is opposite to the angle 90 degree, it is called as an hypotenuse side and it won't change. So I will write this. So this will be hypotenuse side. So you no need to worry about the hypotenuse. I will say angle A. So I will say angle A is theta. So I will say angle A is theta. Now which is opposite side? Which is opposite side and which is adjacent side? Can you identify? Do they vary or not? Yes, they vary because so the angle is changed. Now I will change here. So this is the side which is opposite to angle theta, so BC side, so it will be comes opposite. So the side which is opposite to angle theta will be opposite side, and the side which is theta is lying on the side which is theta is lying, so that is called as adjacent. So this will be adjacent. Got it. So this is what about hypotenuse, adjacent and opposite. Now we will go through trigonometric ratios. So consider a right angle triangle, consider an angle. Using that angle we need to derive some trigonometric ratios. So there are 6 trigonometric ratios. There are 6 trigonometric ratios. One is sine of angle theta, cos of angle or cosine of angle theta, tangent of angle theta, cotangent of angle theta, secant of angle theta, then cosecant of angle theta. So these are the 6 trigonometric ratios. I will write one by one. So trigonometric ratios. First I will write the full forms. So sine of, first one, sine of angle theta. Sine of angle theta. Second one, cosine of angle theta. Third one, tangent of angle theta. If you remember these three things or these three ratios of trigonometry, you can define the other three. What are those? Cot, secant and cosecant. I will write that. So I will say the relations of those things later. So you need to remember that. So fourth one is secant of angle theta. Fifth one is cosecant of angle theta, and the last one is cotangent sine of angle theta, cosine of angle theta, tangent of angle theta, secant of angle theta, cosecant of angle theta, and the last one is cotangent of angle theta. Now I will write the short forms. How they are named as short forms. So I will write those short forms here. So sine of angle theta can be denoted or written as sine theta. Cosine of angle theta can be written as cos theta. Tangent of angle theta can be written as tan theta. Secant of angle theta can be written as secant theta. Cosecant of angle theta can be written as cosecant theta. And last one, cotangent of angle theta can be written as cot theta. So these are the short forms of these 6 trigonometric ratios. Now let us say how those formulas are there. So sine is equal to opposite by hypotenuse. Opposite by hypotenuse. So space will not be there, so I will write like this. For opposite I will write OPP. So hypotenuse I will write HYP. So you need to be remember that. So OPP means opposite. So HYP means hypotenuse. And ADJ means adjacent. Right, so see there, for sine is called as an opposite by hypotenuse. Sine is equal to, or sine theta is equal to opposite by hypotenuse. Cosine, that is cos theta, is equal to adjacent by hypotenuse. And the tangent theta or tan theta can be written as opposite by adjacent. Secant, so secant can be written as hypotenuse by adjacent, and cosecant can be written as hypotenuse by opposite. Then at last cot theta, so that can be written as adjacent by opposite. So you need to remember all those things. So for sine theta you take S. For sine theta you take S. So first letter sine theta S. So S opposite can be written as O and hypotenuse can be written as H. So SOH, sine is equal to opposite by hypotenuse. Sine theta is equal to opposite by hypotenuse. Similarly we can write it as cos is equal to adjacent by hypotenuse, CH. So for tan theta is equal to so if you remember these 3 things, you can write it these another 3 things. So I will say how you can relate those 3 using these 3. So I will say that before that, so sine is equal to opposite by hypotenuse. Sine is equal to opposite by hypotenuse. Cos is equal to adjacent by hypotenuse, and tan is equal to opposite by adjacent. This is what the short forms to remember the trigonometric ratios. Now we have here, so consider this triangle. So other than these things, so you forget about this. So consider this right angle triangle ABC with angle C as theta. Now say which side is opposite and which side is hypotenuse. Let us write like that. So which is opposite here? So opposite is AB. AB by which is opposite AB, hypotenuse is AC. Now for adjacent by hypotenuse, for cos theta is equal to adjacent by hypotenuse, for that BC by AC, right? So which is opposite here? AB. So tan theta is equal to opposite by adjacent, that is AB by BC. Now AC by BC. For this cosecant theta, hypotenuse by opposite, hypotenuse is AC and opposite is AB. So adjacent, for cot theta adjacent by opposite, adjacent is BC and opposite is AB, right? So observe these 6 trigonometric ratios. Can you say what is the relation between these things? So I will say later. So can you observe anything which is related to these 6 trigonometric ratios? Is there any relation between these 6? See here, sin theta. So observe here only, sin theta, cosecant theta. Observe here, sin theta and cosecant theta. What is sin theta? Sin theta is opposite by hypotenuse. What is cosecant theta? Hypotenuse by opposite. That is reciprocal of sin theta is called as cosecant theta. So you can also write this as 1 by sin theta. So if you remember sin theta, what is sin theta? Sin theta is opposite by hypotenuse, right? Opposite by hypotenuse. So that can be written as hypotenuse by opposite. So this is what the cosecant theta, right? If you remember sin theta, you can write cosecant theta. What is cosecant theta? Hypotenuse by opposite. What is that? Is reciprocal of sin theta is called cosecant theta. Like that, can you observe any other things is there or what? Can you observe? See here, cos theta adjacent by hypotenuse. Cos theta is adjacent by hypotenuse. Secant theta is hypotenuse by adjacent. That is the reciprocal of cos theta is called as an secant theta. Reciprocal of cos theta can be written as secant theta. So what is that? That is secant theta. That is equal to 1 by cos theta. So here also the same thing. If you remember the cos theta, what is cos theta? Cos theta is adjacent by hypotenuse, right? That can also be written as hypotenuse by adjacent. So this goes to numerator, right? So this is what? So hypotenuse by adjacent, secant theta. So observe this, tan theta and cot theta. Tan theta and cot theta. So what is tan theta? Tan theta is opposite by adjacent. What is cot theta? Adjacent by opposite. Are they reciprocal? Yes. So 1 by tan theta can be written as cot theta. So what is tan theta? Tan theta is opposite by adjacent. Opposite by adjacent. Right. So adjacent by opposite this can be written as. Right. This is what the cot theta and the tan theta relationship between cot theta and tan theta. So if you remember these 3, you can write these 3. So observe here, sin theta is called as 1 by cosecant theta. This can also be written. Only cosecant theta cannot be written as sin theta. So they are reciprocal. So this can also be written. So cos theta is equal to 1 by secant theta. So that secant theta can be written as 1 by cos theta. So this should also be remembered. So tan theta is equal to 1 by cot theta. Similarly, cot theta is equal to 1 by tan theta. Right. So I think you have understood about this. Now another one relationship is there. Another one relation is there. So I will rub this. So observe here. So observe this tan theta. So tan theta can also be written as sin theta by cos theta. So tan theta can be written as sin theta by cos theta. Why? So see here. What is sin theta? Sin theta is opposite by hypotenuse. And what is cos theta? Cos theta is adjacent by hypotenuse. So this hypotenuse get cancelled. So what will be the remaining? So opposite by adjacent. Have you understood? So tan theta can be written as sin theta by cos theta. Similarly, cot theta can also be written. So because cot theta is the reciprocal of tan theta, so you can write it like cos theta by sin theta. Right. So do this also. Adjacent by hypotenuse, opposite by hypotenuse. So hypotenuse get cancelled. The remaining is adjacent by opposite. Adjacent by opposite. So this is what the relationship between these sin theta, cos theta, and tan theta, and cotangent theta. So now I will write the all relationship near to that, so you can observe that. So I will write the relationship between these 6 things will be here, so you should be remember that also. So sin theta can be written as 1 by cosecant theta. So cos theta can be written as 1 by secant theta. So this can also be written as 1 by cot theta. So this is what secant theta means, 1 by cos theta. So cosecant theta can be written as 1 by sin theta. This can also be written as 1 by tan theta. So these are the relations of these 6 trigonometric ratios. This is about the basics of trigonometric ratios. I think you have understood the concept of trigonometric ratios. Thank you.